Now, in this lecture, we will find the radius of the circle. In the drawing, we have a circle, and inside this circle, we have quadrilateral ABCD, and so quadrilateral ABCD is inscribed by this circle, and we know that side AB of quadrilateral ABCD equals to 3 units, so we will define side AB as A, that is to say AB equals to A, and we know that A equals to 3 units, and we also know that side BC of quadrilateral ABCD equals to 4 units, so we will define side BC of quadrilateral ABCD as B, that is to say BC equals to B, and we know that B equals to 4 units, and we also know that side CD of quadrilateral ABCD equals to 5 units, so we will define side CD as C, and we know that C equals to 5 units, and we also know that side AD of quadrilateral ABCD equals to 6 units, so we will define side AD as D, that is to say AD equals to D, and we know that D equals to 6 units. Okay, and we want to find out the radius of this circle that actually blocks quadrilateral ABCD. Okay, so first of all, I will present to you 3 rules, and we will implement the 3 rules in our drawing, in our circle, and in our quadrilateral ABCD. Okay, so rule number 1 will be that the area of a quadrilateral of a quadrilateral inscribed by a circle equals to so this is the sign of area. It means the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. Here A, B, C, and D are the lengths of quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. Okay, so if you have a quadrilateral that is inscribed by a circle, like in this drawing, then you can find the area of that quadrilateral according to this formula, that the area of the quadrilateral will be equal to the root of s minus a times s minus b times s minus c times s minus d, when s equals to a plus b plus c plus d over 2, and a, b, c, and d are the lengths of the quadrilateral ABC sides. So actually I will draw, I'll show you what rule number 1 means. Actually, if we have this circle and this circle, we have a quadrilateral inside this circle, we have quadrilateral ABCD. Actually, quadrilateral ABCD is blocked by this circle, or quadrilateral ABCD is inscribed in this by this circle. So, rule number 1 states that the area of a quadrilateral inscribed by a circle, actually here quadrilateral ABCD, is inscribed by this circle. And we also know that side AB of quadrilateral ABCD equals to A units in its size, side BC of quadrilateral ABCD equals to B units in its size, that is to say BC equals to B, side CD of quadrilateral ABCD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size, that is to say AD equals to D, or the size of AD is D units. So according to rule number 1, the area of a quadrilateral inscribed by a circle, so the area of this quadrilateral that it is inscribed by this blue circle equals to the root of s minus a times s minus b times s minus c times s minus d. Okay, so the area of this quadrilateral ABCD, I will repeat again that this is the sign of the area of quadrilateral ABCD, and according to rule number 1, the area of this quadrilateral ABC that it is inscribed by this blue circle equals to the root of s minus a times s minus b times s minus c times s minus d, when a, b, c, and d are actually the lengths of quadrilateral ABC sides. This is a, this is b, this is c, and this is d. It means, for example, that side AD equals to d units in its size, side AB equals to a units, side BC equals to b units, and side DC equals to c units in its size, and S equals to a plus b plus c plus d over 2. So if you have a quadrilateral like this quadrilateral ABCD that is inscribed by a circle, like in this drawing, then you can calculate the area of this quadrilateral, according to this formula, when S equals to A plus B plus C plus D, and A, B, C, and D are the lengths of this quadrilateral ABCD sides. Okay, so that is rule number 1. Whenever you have a quadrilateral that it is inscribed by a circle, like in this drawing, you can calculate the area of this quadrilateral according to this formula, and S equals to A plus B plus C plus D over 2, and A, B, C, and D are the lengths of the quadrilateral ABCD sides. Okay, so that is rule number 1, and we have also rule number 2. Rule number 2 states that if a quadrilateral is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. I read rule number 2 again. Rule number 2 states that if a quadrilateral is inscribed by a circle, then the product of its diagonals equals to the sum of products of its opposite sides. So, what is the meaning of rule number 2? According to rule number 2, if you have this circle and inside this circle we have quadrilateral ABCD, and again we know that side AB equals to A units in its size, side BC equals to B units in its size, side CD equals to C units in its size, and side AD equals to D units in its size. And we also know that quadrilateral ABCD has two diagonals. The first diagonal is DB, and the second diagonal is AC. And diagonal DB equals to X units in its size, that is to say DB equals to X, so the size of DB is X units, and the size of diagonal AC is Y units, that is to say AC equals to Y. Then, according to rule number 2, if a quadrilateral is inscribed by a circle. Like in this drawing, we have quadrilateral ABCD, that it is inscribed by this blue circle. Then the product of its diagonals. Again, diagonal ABCD, quadrilateral ABCD has two diagonals, diagonal AC and diagonal BD, and the size of diagonal BD is X units, and the size of diagonal AC is equals to Y units. According to rule number 2, the product of its diagonals, that is to say X times Y, equals to the sum of the products of its opposite sides. Actually, quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides are AD, that is the opposite sides of BC, and we know that AD equals to D units in its size, and BD equals to BC equals to B units in its size. And according to rule number 2, the product of its diagonals equals to the sum of the products of its opposite sides. So the product of the first opposite sides is actually B times D, and we also have the second pair of opposite sides. Side AB is opposite to side DC, and we know that side AB equals to A units in its size, and side DC equals to C units in its size, and the product of those two opposite sides is AC, A times C. And according to rule number 2, the product of its diagonals, that is to say X times Y, equals to the sum of products of its opposite sides. So here we have the first product of its opposite sides is BD, and the second product of its opposite sides is AC, and the sum of the products of its opposite sides is BD plus AC. So according to rule number 2, the products of its diagonals, that is to say X times Y, equals to the sum of the products of its opposite sides. That is actually the first product is BD and the second product is AC. The first product of its opposite sides is BD, and the second product of its opposite sides is AC, and the sum of the products of its opposite sides is BD plus AC, and that sum of the products of its opposite sides, that is BD plus AC, equals to the products of its diagonals, that is to say X times Y, or X times Y, that is the product of its diagonals, equals to the sum of the products of its opposite sides, equal to BD plus AC. Okay, I will read rule number 2 again. If a quadrilateral is inscribed by a circle, this quadrilateral ABCD is inscribed by this blue circle, then the product of its diagonals, the product of quadrilateral ABC diagonals is X times Y. That product of its diagonals equals to the sum of products of its opposite sides, and the sum of the products of its opposite sides is BD plus AC, or X times Y, the product of its diagonals, equals to the sum of the products of its opposite sides, that is to say it equals to BD plus AC, or XY equals to BD plus AC. That is the meaning of rule number 2. Okay? And we also have Rule number 3. Rule number 3 states that if a triangle is inscribed by a circle, then the radius of that circle equals to the product of the triangle's sides over 4 times the area of that triangle. So I will read rule number 3 again. Rule number 3 states that if a triangle is inscribed by a circle, then the radius of that circle equals to the product of the triangle sides over 4 times the area of that triangle. The area of that triangle. The area of the triangle that it is inscribed by a circle or by that circle. So what is the meaning of rule number 3? The meaning of rule number 3 is that if you have this circle and this circle is block triangle ABCD, or triangle ABC is inscribed by this circle. So we have triangle ABC that is inscribed by this circle. The meaning of the sentence that triangle ABC is inscribed by a circle or by this circle is actually that ABC, the meaning of the sentence that triangle ABC is inscribed by a circle, it means that all of 3 vertices of triangle ABC lie on this circle. As you can see, vertex A, vertex B, and vertex C, all of those 3 vertices lie on the circle, and the triangle is inside the circle. That is the meaning of the sentence that triangle ABC is inscribed by a circle. Okay? So, what is the meaning of rule number 3? If a triangle is inscribed by a circle, like this triangle ABC is inscribed by this circle, by the blue circle, And we also know that side AB equals to A units in its size, side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. This is to say AC equals to C, or the size of AC is C units. Okay, so what is the meaning of rule number 3? If a triangle is inscribed by a circle, like this triangle ABC, it is inscribed by this blue circle, then the radius of that circle, the radius of this blue circle that blocks triangle ABC equals to the product of the triangle sides. So the radius of this blue circle that blocks triangle ABC, that is to say capital R, equals to the product of triangle sides. The product of triangle ABC sides is actually A times B times C over 4 times the area of the triangle, over 4 times the area of triangle ABC, over 4 times the area of triangle ABC. Okay, that is the meaning of rule number 3. If you have a triangle that is inscribed by a circle, then the radius of that circle that blocks the triangle will be equal to the product of the triangle's sides that it blocks times 4 times the area of the triangle that the circle blocks. In our case, the blue circle blocks triangle ABC, or triangle ABC is inscribed by this blue circle. Therefore, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, and the product of triangle ABC sides, it is actually A times B times C over 4 times the area of this triangle that is blocked by this blue circle. And so it is 4 times the area of triangle ABC. So if you have a triangle that is inscribed by a circle, the radius of that circle will be equal to the product of the triangle sides over 4 times the area of the triangle. I'll read rule number 3 again. If a triangle is inscribed by a circle, so this triangle ABC is inscribed by this blue circle, then the radius of that circle, the radius of this blue circle, equals to the product of the triangle sides. The product of this triangle sides, it is actually A times B times C over 4 times the area of that triangle, over 4 times the area of triangle ABC that it is blocked by this circle. So the radius of a circle that blocks a triangle equals to the product of the triangle that it blocks over 4 times the area of the triangle that it blocks. So in this drawing, the blue circle blocks triangle ABC, therefore its radius will be the product of the triangle that it blocks, that is to say A times B times C over 4 times the area of this triangle, over 4 times the area of triangle ABC. Okay, so actually that is the meaning of rule number 3. So we will actually implement rule number 3 in our drawing. In our drawing, we will implement rule number 1. According to rule number 1, the area of this quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. Okay, according to rule number 1, the area of quadrilateral ABCD equals to this formula when A, B, C, and D are the lengths of this quadrilateral. A equals to 3, B equals to 4, C equals to 5, and D equals to 6 units. And S equals to A plus B plus C plus D over 2. This is according to rule number 1. We will implement rule number 2 in our drawing. According to rule number 2, if you have a quadrilateral that is inscribed by a circle, like in this drawing, quadrilateral ABCD is inscribed by this blue circle, then the product of its diagonals, this is to say, quadrilateral ABCD has two diagonals. Diagonal AC, we define the size of diagonal AC as x, that is to say AC equals to x units, and we will define the size of diagonal BD as y, that is to say BD equals to y. So according to rule number 2, the product of its sides, that is to say x times y, equals to the sum of the products of its opposite sides. The first product of its opposite sides is BD, and the second product of its opposite sides is AC. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. And the sum of the product of its opposite sides, it is actually BD plus AC. That is to say xy equals to BD plus AC. That is the implementation of rule number 2 in our drawing. Okay, the product of its diagonals is xy, and that product equals to the sum of the products of its opposite sides. The first product of its opposite sides is BD, the second product of its opposite sides is AC, and according to rule number 2, it equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides is BD plus AC, and it is equal to the products of its diagonals, that is to say xy, or xy equals to BD plus AC according to rule number 2. Okay, and we will implement also rule number 3 in our drawing. If we relate to triangle ABC, as you can see from the drawing, triangle ABC, this triangle ABC is triangle ABC is inscribed by this blue circle. Therefore, according to rule number 4, the radius of this blue circle will be equal to the product of triangle ABC sides, and the product of triangle ABC sides is A times B times X over 4 times the area of triangle ABC, over 4 times the area of triangle ABC. Okay, this equality is true according to rule number 3. Why? Because triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABC equals to the products of its sides, the products of triangle ABC sides, that is to say 2A times B times X, over 4 times the area of triangle ABC. Okay, so here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC equals to ABX over 4. Okay, so we multiplied this equation number 3, by the area of triangle ABC, and we got that R times the area of triangle ABC equals to ABX over 4. Here we will divide equation number 3 by R, and we will get the area of triangle ABC. We will get that the area of triangle ABC, according to equation number 3, equals to ABX over 4R. So we actually found out the area of triangle ABC. In the next step, we will focus on triangle ADC. We will focus on triangle ADC. Triangle ADC. As you can see from the drawing, this triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle will be equal to the product of the of triangles ADC sides. That is to say, it will be equal to C times D times X over 4 times the area of this triangle ADC. Four times the area of triangle ADC. This is the radius of the circle that blocks triangle ADC. So here we'll multiply equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to CDX over 4. Here we will divide equation number 4 by R, and we will get that the area of triangle ADC, according to equation number 4, equals to CDX over 4R. So we actually found out the areas of triangle ABC and the area of triangle ADC. Okay? But as you can see from the drawing, quadrilateral ABCD consists of those two triangles, triangle ABC and triangle ADC. Therefore, the area of triangle of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. So I will write it down that the area of quadrilateral ABCD will be equal to the area of triangle ABC, this triangle, plus the area of triangle ADC. Because actually quadrilateral ABC consists of those two triangles. Therefore, the sum of the areas of those two triangles will be equal to the area of quadrilateral ABCD. Very simple. You can see it also from the drawing. Okay, quadrilateral ABCD consists of those two triangles. Therefore, the area of quadrilateral ABCD will be equal to the area of to the sum of the areas of those two triangles. I will repeat again, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. So we can write down that the area of quadrilateral ABCD will be equal to the area of triangle ABC, but we have already found out that the area of triangle ABC equals to ABX over 4R plus the area of triangle ADC. But we have already found out that the area of triangle ADC equals to CDX over 4R. So here we will take x over 4r as a common factor of those two expressions, and we will get that the area of quadrilateral ABCD equals to x over 4r is a common factor of those two expressions, and inside the brackets we will have AB plus here CD. Okay, so we actually found out that the area of quadrilateral ABCD equals to x over 4r times AB plus CD. Okay, so in the next step we will focus on this triangle BDC. So in triangle BDC, so here, as you can see from the drawing, this triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle will be equal to the products of triangle BDC sides. It will be equal, again, the radius of the blue circle will be equal to the product of triangle BDC sides, that is to say, it will be equal to B times C times Y over 4 times the area of this triangle BDC, that is according to rule number 3. Okay. So here we will multiply equation number 5 by the area of triangle BDC, and we will get that the area of triangle BDC times R equals to BCY over 4. Here we will divide equation number 5 by R, and we will get the area of triangle BDC. We will get, according to equation number 5, the area of triangle BDC equals to BCY over 4R. Okay, we divided equation number 5 by R, and we got that the area of triangle BDC equals to BCY over 4R. Okay, so in the next step we will focus on triangle ABD. This triangle ABD. As you can see from the drawing, triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle will be equal to the product of triangle ABD sides, that is to say, it will be equal to A times D times Y over 4 times the area of this triangle ABD. Okay, this is actually according to rule number 3. I will repeat again. This triangle ABD is inscribed by this blue circle, therefore according to rule number 3, the radius of the circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say, it will be equal to A times D times Y over 4 times the area of this triangle ABD. Here we will, according to rule number 3, we will multiply equation number 6 by the area of triangle ABD, and we will get that R times the area of triangle ABD equals to A dy over 4. Here we will divide equation number 6 by R, by the radius of the circle, and we will get that the area of triangle ABD according to equation number 6 equals to A dy over 4R. Okay? We actually found out that the areas of triangle ABD and the area of triangle BDC. Okay? But what is the sum of the areas of triangle ABD and triangle BDC? The sum of the area of triangle BDC plus the area of triangle ABD equals exactly to the area of quadrilateral ABCD, because of the fact that quadrilateral ABCD consists of those two triangles. Therefore, the sum of the areas of those two triangles will be equal to the area of quadrilateral ABCD. Very simple. So we write it down. Question number 2 will be that the area of quadrilateral ABCD equals to the area of triangle BDC, this triangle, plus the area of triangle ABD, this triangle. You can see it from the drawing. It is very simple. If you add triangle, combine triangle BDC with triangle ABD, you will receive the quadrilateral ABCD. Therefore, the sum of the areas of those two triangles will be equal to the area of quadrilateral ABCD. Very simple. I will repeat again. According to equation number 2, the area of quadrilateral ABCD equals to the area of triangle BDC plus the area of triangle ABD. Very simple. But what is the area of quadrilateral ABCD? The area of quadrilateral ABCD equals to the area of triangle BDC. We have already found out that the area of triangle BDC equals to BCY over 4R plus the area of triangle ABD. We have already found out that the area of triangle ABD equals to ADY over 4R. So here we will take a common factor of y over 4R out of these expressions, and we will get that the area of quadrilateral ABCD equals to, so as I already said, we take a common factor of y over 4R out of these expressions, and what is left after we took a common factor of y over 4R out of these expressions inside the brackets, we will have from this expression, what is left is BC, and what is left in from this expression is AD. Okay, so we found out that the area of quadrilateral ABCD according to equation number 2 equals to y over 4R times BC plus AD. But we have already found out that the area of quadrilateral ABCD according to equation number 1 equals to x over 4R times AB plus CD. So actually have two different expressions for the area of quadrilateral ABCD. So here we will multiply equation number 1 by equation number 2 and we will get equation number 3. Equation number 3 will be the area of quadrilateral ABCD squared will be equal to x times y over 4r squared times BC plus AD times AB plus CD. Here we will take a root out of this equation number 3 and we will get that the area of quadrilateral ABCD according to equation number 3 equals to the root of this expression, the root of xy times BC plus AD times AB plus CD. Over, actually the root of 4r squared is 4r. Why? Because the square cancels the root. Okay, we took a root for 4r squared. The square cancels the root, and what is left after the square cancels the root? Only 4r. Okay, so we actually found out that the area of quadrilateral ABCD equals to this expression. So here we will multiply equation number 3 by r and then we will divide it by the area of quadrilateral ABCD and we will get that r times the area of quadrilateral ABCD equals to the root of xy times BC plus AD times AB plus CD. Over 4. So here we multiplied equation number 3 by r and we got this expression. Here we will divide the equation number 3 by the area of quadrilateral ABCD and we will get the radius that we are looking for, r. So we will divide the equation number 3 by the area of quadrilateral ABCD and we will get that r equals to the root of xy BC plus AD times AB plus CD over 4 times the area of quadrilateral ABCD. So we divided this equation number 3 by the area of quadrilateral ABCD and we got this expression. Here we know that according to rule number 2, xy equals to AC plus BD. xy equals to AC plus BD. Therefore, we can substitute xy in this equation number 3 by AC plus BD because xy equals to AC plus BD. Okay, we'll do it now. We will get that the radius of the circle that we are looking for equals to, so instead of xy we will write down AC plus BD, that equals to xy times BC plus AD times AB plus CD over 4 times the area of quadrilateral ABCD. So here we know the values of ABCD, and the only thing that is left to find out is to find out the area of quadrilateral ABCD, and we will find out the area of quadrilateral ABCD according to rule number 1. Actually, we have already found out the area of quadrilateral ABCD, so I will repeat again on the same equation. The area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. And S equals to A plus B plus C plus D over 2. This is something that we have already found out. We found out that the area of quadrilateral ABCD equals to this expression. So I will write down the values of A, B, C, and D. A equals to 3 units, it is given as the question. B equals to 4 units, C equals to 5 units, and D equals to 6 units. So therefore S will be equal to A is 3, B is 4, C is 5, and D is 6 over 2. So 3 plus 4 is 7, 7 plus 5 is 12, and 12 plus 6 is 18, and 18 over 2 is 9, so we found out that S equals to 9. S equals to 9, so we'll substitute S in this equality by 9, because S equals to 9, and we will find out that the area of quadrilateral ABCD actually equals to the root of S minus A. S is 9, A is 3, so it is 9 minus 3. S minus B, S is 9 and B is 4, so it is 9 minus 4. S minus C, S is 9 and C is 5, so it is 9 minus 5. And we have S minus D. S is 9 and D is 6, so it is 9 minus 6. So we found out that the area of quadrilateral ABCD equals to the root of 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. So it equals to the root of this expression, so the area of quadrilateral ABCD equals to the root of 6 times 5 is 30, and 30 times 4 is 120. 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to 300 to the root of 360 square units. So we can substitute here the area of quadrilateral ABCD by the root of 360 square units. Okay, so we'll do it now, and we will get that the radius of the circle R equals to the root of AC plus BD relate to this equation number 3, AC plus BD times BC plus AD times AB plus CD and we have already found out that the area of quadrilateral ABCD equals to the root of 360, so it is 360 times 1 over 4. So we actually found out that the radius of the circle equals to this expression. Here we substituted ABCD by the root of 360 and we got this expression. So we know the values of A, B, C and D, so we find out the radius by doing this simple arithmetic. We know that C equals to 3 units, B equals to 4 units, A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. Okay, so the radius of the circle, according to equation number 3, R, will be equals to 1 over 4 times the root of AC. A is 3, C is 5, 3 times 5 is 15, plus BD, B is 4, D is 6, 4 times 6 is 24, times BC. B is 4, C is 5, 4 times 5 is 20, plus AD. A is 3, D is 6. 3 times 6 is 18, times AB. A is 3, B is 4, 3 times 4 is 12, plus CD. C is 5, D is 6, so 5 times 6 is 30, over 360. So the radius of the circle equals to 1 over 4 times the root of 15 plus 24 is 39, 20 plus 18 is 38, and 12 plus 30 is 42, over 3 is 36. So the radius of the circle equals to 1 over 4 times the root of, here 39 times 38 times 42 over 36 is 172.9. Okay, so we actually found out that the radius of the circle R equals to the root of 172.9 over 4 units. The radius of the circle equals to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. I will repeat again. We found out that the radius of this circle that blocks quadrilateral ABCD equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. Quadrilateral ABCD is inscribed by this circle, and we want to find out the radius of this circle. We know that in quadrilateral ABCD, side AB equals to 3 units, so we define side AB as A, and A equals to 3 units, and we also know that side BC equals to 4 units, so we define side BC as B, and B equals to 4 units, and we also know that side CD equals to 5 units, so we define side CD as C, and C equals to 5 units, and AD equals to 6 units, so we define side AD as D, and D equals to 6 units, and we want to find out the radius of this circle. Okay, so actually, in order to find out the radius of this circle, I presented to you 3 new rules, and we implemented those 3 new rules in our drawing. We have our first rule. Our first rule states that if the area of a quadrilateral inscribed by a circle equals to this expression, the area of quadrilateral ABCD, this quadrilateral that inscribed by this blue circle, will be equal to the root of S minus A times S minus B times S minus C times S minus D, and A, B, C, and D are the lengths of this quadrilateral ABCD, and S equals to A plus B plus C plus D over 2. So if you have a quadrilateral that is inscribed by this circle, then the area of this quadrilateral will be equal to this expression. Here S equals to A plus B plus C plus D, and A, B, and C and D are the lengths of this quadrilateral sides. Okay, that is rule number 1, and I also presented to you rule number 2. According to rule number 2, if a quadrilateral is inscribed by a circle, then the products of its diagonals equals to the sum of the products of its opposite sides. So, if a quadrilateral is inscribed by a circle, this quadrilateral ABCD is inscribed by this blue circle. Therefore, the products of its diagonals, that is to say, a quadrilateral ABCD has 2 diagonals, diagonal AC and diagonal BD. Diagonal AC equals to Y units in its size, and diagonal BD equals to X units in its size. So according to rule number 2, if we have quadrilateral ABC that is inscribed by a circle, then the product of the diagonals, that is to say X times Y, will be equal to the sum of the products of its opposite sides. Actually, quadrilateral ABCD has 2 opposite sides, 2 pairs of opposite sides. The first pair is AD, is the opposite sides of BC, and the second pair AB is the opposite sides of DC. The first product is B times D. The second product is A times C. And according to rule number 2, the product of the diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, and the sum of the products of its opposite sides is BD plus AC. So the product of its diagonals is x times y, and the product of its opposite, the sum of the products of its opposite sides is BD plus AC. And according to rule number 2, the product of its diagonals, that is x times y, equals to the sum of the products of its opposite sides, that is BD plus AC. That is to say, xy equals to BD plus AC. Okay, that is rule number 2. Whenever you have a quadrilateral that is inscribed by a circle, like in this drawing, then the product of the diagonals, that is x times y, will be equal to the sum of the products of its opposite sides, and the sum of the products of its opposite sides is BD plus AC. It equals to x times y, that is the product of its diagonals. So the products of the diagonals of quadrilateral ABCD is x times y, and it equals to the sum of the products of its opposite sides, that is BD plus AC. xy equals to BD plus AC. Okay, that is rule number 2. And we also have rule number 3. Rule number 3 states that if a triangle is inscribed by a circle, then the radius of that circle equals to the product of the triangle sides over 4 times the area of that triangle. So if a triangle is inscribed by a circle, like in this drawing, we have triangle ABC that it is inscribed by the blue circle, then the radius of that circle, the radius of this circle that blocks triangle ABC will be equal to the product of the triangle sides. The product of the triangle sides is A times B times C over 4 times the area of the triangle that is inscribed by this circle. So it is A times B times C over 4 times the area of this triangle, triangle ABC. So whenever you have a triangle that it is inscribed by a circle, then the radius of the circle that blocks the triangle will be equal to the product of the triangle sides, that is to say A times B times C, over 4 times the area of the triangle, that is 4 times the area of triangle ABC. Okay, that is all number 3, and we implemented all 3 rules in our drawing. We implemented the first rule. According to the first rule, the area of a quadrilateral that is inscribed by a circle, like in this drawing, equals to the area of quadrilateral ABCD equals to the root of S times A times S times B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. Okay, so if you have a quadrilateral that is inscribed by a circle, then the radius of this circle will be equal to the if you have a quadrilateral that is inscribed by a circle, then the area of this quadrilateral will be equal to the root of S minus A times S minus B times S minus C times S minus D, and S equals to A plus B plus C plus D over 2, and A, B, C, and D are the lengths of this quadrilateral ABCD. So if a quadrilateral is inscribed by a circle, like in this drawing, then you can calculate the area of this quadrilateral ABCD according to this formula. Okay, and we also implemented rule number 2 in our drawing. According to rule number 2, if you have quadrilateral that it is inscribed in a circle like in this drawing, then the product of the quadrilateral diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. And the sum of the products of its opposite sides is BD plus AC. So the product, if it is of its diagonals, that is x times y, will be equal to the sum of the products of its opposite sides. That is to say, will be equal to BD plus AC. Okay, so if you have a quadrilateral that is inscribed in a circle, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, will be equal to BD plus AC. Okay, that is rule number 2, and we have also rule number 3, that if you have a triangle that is inscribed by a circle, like in our drawing, we have a triangle ABC that is inscribed by this blue circle. Therefore, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say, will be equal to A times B times X over 4 times the area of this triangle over 4 times the area of triangle ABC. So according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of the triangle sides, that is to say, it will be equal to A times B times X over 4 times the area of triangle ABC. Okay, over 4 times the area of this triangle, triangle ABC. So R equals to ABX over 4 times the area of that triangle that is blocked by that circle. Okay, so here we multiplied equation number 3 by the area of triangle ABC, and we got that R times the area of triangle ABC equals to ABX over 4. We divided equation number 3 by R, and we got that the area of triangle ABC equals to ABX over 4R. Then we related to triangle ADC. This triangle ADC is blocked by this blue circle. On triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the triangles ADC, the product of triangles ADC sides, that is to say, will be equal to C times D times X over 4 times the area of triangle ADC. This is according to rule number 3. Okay, here we multiplied the equation number 4 by the area of triangle ADC, and we got that R times the area of triangle ADC equals to CDX over 4. We divided the equation number 4 by R, and we got that the area of triangle ADC equals to CDX over 4R. So we got the areas of triangle ABC and the area of triangle ADC. Okay, but we know that the area of triangle ABC plus the area of triangle ADC equals exactly to the area of quadrilateral ABCD. I will repeat again, the area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC, because of the fact that quadrilateral ABCD consists exactly those two triangles. Therefore, the sum of the areas of those two triangles will be equal to the area of triangle ABCD. Very simple. So the area of quadrilateral ABCD equals to the area of triangle ABC. We have already found out that the area of triangle ABC equals to ABX over 4R plus the area of triangle ADC. We have already found out that the area of triangle ADC equals to CDX over 4R. Okay, so we found out that the area of quadrilateral ABCD, according to equation number 1, equals to ABX over 4R plus CDX over 4R. We took a common factor of x over 4r out of these expressions, and we got that the area of triangle ABC equals to x over 4r times AB plus CD. Then we related to triangle BDC. This triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle equals to the product of triangle BDC sides. That is to say, it equals to B times C times Y over 4 times the area of triangle BDC. Okay, according to rule number 3, the radius of the circle that blocks triangle BDC equals to the products of triangle BDC sides, that is B times C times Y over 4 times the area of triangle BDC. According to rule number 3, here we multiply the equation number 5 by the area of triangle BDC, and we got this R times the area of triangle BDC equals to BCY over 4. Here we divided the equation number 5 by the area of triangle BDC, and we got that the area of triangle BDC equals to BCY over 4R. Okay? Then we related to triangle ADB. This triangle, as you can see from the drawing, this triangle ABD, is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABD will be equal to the products of triangle ABD sides, that is to say, will be equal to A times D times Y, will be equal to A times D times Y over 4 times the area of triangle ABD over 4 times the area of this triangle. According to rule number 3, we multiplied equation number 6 by the area of triangle ABD, and we got that R times the area of triangle ABD equals to ADY over 4. We divided equation number 6 by the area of triangle by R, and we got that the area of triangle ABD equals to ABY over 4R. So we found out the areas of triangle BDC and the area of triangle ABD. But we know that the area of triangle BDC plus the area of triangle ABD equals exactly to the area of quadrilateral ABCD, because of the fact that quadrilateral ABCD consists of those two triangles. Therefore, the sum of the areas of those two triangles will be equal to the area of triangle of quadrilateral ABCD. So I repeat again, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. Okay, so the area of quadrilateral ABCD equals to the area of BDC, but we have already found out that the area of triangle BDC equals to BCY over 4R, and the area of triangle ABD equals to ABY over 4R. Here we took a common factor of y over 4R out of these expressions, and we got, according to equation number 2, that the area of quadrilateral ABCD equals to y over 4R times BC plus AD. But we have already found out, according to equation number 1, that the area of quadrilateral ABCD equals to x over 4R times AB plus CD. So we multiplied the equation number 1 by equation number 2, and we got that the area of quadrilateral ABCD squared equals to this expression. We took out a root of equation number 3, and we got that the area of quadrilateral ABCD equals to the root of this expression, and the root of 4R squared equals to 4R. Okay? So here we multiplied this equation number 3 by R, and we got that R times the area of quadrilateral ABCD equals to this expression. We divided the equation number 3 by the area of quadrilateral ABCD, and we got that the radius of the circle that we are looking for equals to this expression. And according to rule number 2, xy equals to AC plus BD, so we can substitute xy by AC plus BD, because xy equals to AC plus BD, very simple. So we substituted xy in this equation number 3 by AC plus BD, and we got this expression. So the only thing that is left to find is to find out the area of quadrilateral ABCD. Okay, and we found out the area of quadrilateral ABCD according to rule number 1, it equals to this expression, and S equals to A plus B plus C plus D over 2. We know that A equals to 3, B equals to 4, C equals to 5, and D equals to 6. Therefore, S will be equal to A plus B plus C plus D. It is actually 18 over 2. So S equals to 9. And we substitute S by 9 in this equality, and we got that the area of quadrilateral ABCD equals to S minus A, S minus A. S is 9, A is 3, so S minus A is 9 minus 3, S minus B is 9 minus 4, S minus C is 9 minus 5, S minus D is 9 minus 6. And we subtracted those expressions. 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. And the multiplication of 6 times 5 times 4 times 3 is 360, so we found out that the area of quadrilateral ABCD equals to the root of 360. So we substituted the area of quadrilateral ABCD by the root of 360, and we got this expression. So here we know all the values. AC, A is 3, C is 5, so 3 times 5 is 15. BD, B is 4, D is 6, so 4 times 6 is 24. Here BC, B is 4, C is 5, so 4 times 5 is 20. AD, A is 3, D is 6, so 3 times 6 is 18. AB, A is 3, B is 4, 3 times 4 is 12. And we have CD, C is 5, D is 6, so 5 times 6 is 30. So we got this expression. 15 plus 24 is 39, 20 plus 18 is 38, and 12 plus 30 is 42. So the root of 39 times 38 times 42 over 46 is 172.9. So we found out that the radius of the circle equals to either 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. I will repeat again. The radius of this circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, thank you very much.